All right. Can you, I think you can hear me, right? Somebody say yes.
Yes.
Okay, good. So yeah, I have changed my background because now I'm in Canada right now. And yeah, you may not be able to see, but it's snowing outside, so it's quite white. Yeah, usually it's the first time I do that. It's just overtime. So I wouldn't normally add some extra class for just for fun. But since there was COVID and everything was distance learning and stuff, so I thought, oh, maybe you guys still have questions, and it was so I just want to make sure that you have the best conditions possible for the final exam. So if you have extra questions, here's the time to ask them, or later I can still answer them. Yeah, so the program is really simple. I'm just going to go over some interesting questions I have received, and we can answer them together. And if you have extra questions, then you can go ahead and ask them. I'll do my best to answer them as quickly as possible. Okay, so let me just share my screen. Yeah, so I thought like we could go for an hour and a half, depends how many questions there are. Okay. Interpret the socially efficient number of boats. So that's, oh yeah, so I'll go chapter 2, chapter 3, chapter 4. Some of questions are about the TD questions, or about some are about the class, so both are important. So I'll answer both of them. So the socially efficient number of boats, what is it? Let me just write it again. It's G star O equals R divided by 2. So, oh yeah, questions I have received a lot. So do I need to remember all the formulas? No. So what I'm going to give you is, so I could ask you something like, why does X or Y happens in some model? And this is some general result about a model. So I would expect you to remember. So for instance, that there is the number of boats in the socially efficient market is usually smaller than the number of boats in the open open exploitation market. So this is, so if I ask you why is that the case, so it's not like you have to remember the exact formula, but you have to remember that this is the case and why, for instance. But in terms of the models, what I'm going to do is give you, like, tell you, oh, this is the model, and so this is the formula you need, and now please tell me this or compute me that. So then you can use the formula and compute stuff with it. So you don't need to remember by heart all of this, like what I'm writing there. I don't know them by heart. It's just I prepared before. So, but it's not bad to kind of remember how things look like, because then in the exam, if you derive something and then you find that doesn't look familiar, then you know you may have made some computing mistake. So it's for you, but personally, I think it's not bad to just remember some aspects of the formulas. Depends on your strategy. Okay, so interpret the socially efficient number of bolts. So this is the socially efficient number of bolts. So we can interpret it. So yeah, so I could write something like dB x is larger than 0 for x. So R K and yeah, dB 0 dB. So this is something that economists always do. So it's called comparative statics. So we find a solution to our problem. So this is the solution we found, efficient number of volts. And then, so what we say is we make our formulas talk. So we interpret what we get and think about what this means and why it makes or doesn't make sense. So it's smaller than 0 for actually for just C. Yeah, for C. And ambiguous for alpha. All right, so can somebody have a crack at this? So interpret why this is the case. Why is the socially efficient number of volts increasing if R increases or P or K?
For instance, for K, if the carrying capacity increases, then there will be more space for fish to develop and grow. And then as the number of fish will be bigger, the number of boats that can enter the lake to fish will be greater too.
Yes, so of course, if you have a very small pond, then you just need one small boat and you catch everything you can catch. But if it's the ocean, then you can catch many more fishes. So it's socially efficient to put more boats in the ocean. Also I could add this part there. We also find that this is equal to B star F divided by 2. Or in other words, B star F was equal to this. So the same thing can be said for B star F. So if it's socially efficient number of boats or the open fishing industry, in both cases, you have more boats in the ocean because there is more profits. So perfect. Other comments about R, for instance? So you have to remember that R is the rate of regeneration of the stock. So why would that have a positive impact? Well, it's the same mechanism as K. So same as K. If fishes grow very quickly, then you can harvest more of them. So right. So this is typically a kind of set of questions I would ask. So interpret something, there is some formula, but it's the first step is to say, oh yeah, well, the relation between B star O and some variable is positive or is negative. So that's being able to interpret a mathematical formula, but then understanding what this means. All right, P.
Probably because if the prices increase, then there will be more fisher motivated to go fishing, so they can make a bigger profit because the cost of a boat doesn't change.
Yes, so I could even add P and C here. So because it's kind of the same thing. C is how much it costs me to rent a boat, and P is when I'm done fishing, how much profit can I make, or how much revenue can I have? So P, more revenue from selling fishes, and C, higher cost. So obviously C decreases.
The sign of the derivative would be different if with C, because if it costs more, no?
Yeah. It's negative. Yeah, it's here.
Okay.
It's just I wanted to put that in the same because the both of them are kind of superfluous in a way. So it's you could have that the price. Well, no, not exactly. Yeah, let me put them separately. P more and C higher cost. So should catch more fishes per boat. So what happens is if it costs a lot to rent a boat, then I have to catch maybe 100 fishes with that boat instead of 50 to make a profit. So then I have to put fewer boats on the ocean. And so alpha, this is trickier.
It's ambiguous because it depends of the on the quality of the technology. Because if the quality of fishing is very good, it would need to be less boats to catch the same amount of fish. However, if the quality is not good at all, there would need to have lots of boats to catch the same amount.
So what you're saying is if alpha is very low, I should put many boats.
Yes.
So is that the case? It's ambiguous, right?
Yes, we can't really know because there is two parts in which alpha is the first one with R over alpha. So here, if alpha is high, the number of boats decrease. However, in the second part, because there is a negative sign in front of the ratio, when the alpha will increase, the C over P alpha K would decrease. So the total number of boats will increase.
Yes, so it's 3/4 good. So exactly, so your mindset is very good in the sense that when you have ambiguous answers like this, the best is to think about extreme cases. So and then you ask yourself what would happen. So imagine that alpha is extremely high. So let me put that. If alpha is extremely high, extremely high. Oops. So this, you said that perfectly. So I only need a single bolt to catch all the fishes. So l'eau, is that not star? But then you said, oh, if the technology is very bad, I need many bolts. It's true if what you want is to catch a certain number of fish, then if your technology is very good, you only need one bolt. If your technology is very bad, you need maybe 100 bolts. But then what we know is it's if the technology is very bad, also I will not use a lot of bolts. And why would that be the case?
Because of the cost of fishing?
Yes. So imagine that alpha equals 0. Just take that at the extreme. What would you do? Well, my profit from fishing is just minus C because I caught no fish at all. So obviously I would put 0 boat in the ocean. Yeah. So these are tricky questions. So if you just look at the equation, it's, you get alpha the denominator everywhere. So you're like, yeah, I don't know if alpha is 0, I get infinity. So it's at some point, of course, this such equation necessitates that alpha is not 0. Otherwise, it doesn't. You can compute anything. But so logically, if you want to understand why it's ambiguous, that's the kind of reasoning that you have. All right. Why does the socially optimal fishing depend on free and free? Yeah. Okay. So this is it's not that BO is depends on BF. It's just that we happen to find out that BO equals BF over 2. And I wanted to highlight that there is this this thing going on with the 2, that we found that BO is exactly 1/2 of BF. So it means that it's socially beneficial to always put half of the bolts that you would have put otherwise. And why does that do we find this? This is it may look surprising, and counterintuitive. So why do we find this relationship? It really comes from the type of functions that we were using. So let me find yeah. So my profit is the following. Yeah, okay. So the revenue from fishing. It's so I get R. Was it? Is it R? Oh, wait a second. I'll find it again. Yeah, okay. It's P alpha S star B star F of star minus C. So that's profit from fishing. So let me P of S star. And then what did I find? I find that, so it's a function of the stock of fish. Yeah, okay. So this is the profit from one boat. Yeah, exactly. So yeah, let me put, yeah, so the total profit, what is it? It's B star. Okay, now we're going somewhere. Okay, so this is the profit from one boat. It's the sales price of a fish times alpha times the stock, so how many fish I'm going to catch, minus the rental cost of the boat. And then what I'm looking is for the total industry profit. Yeah, industry profit. Profit from fishing. And in the free entry, what I found was it's always the same. It's profit equals 0. So let me put this way, equals 0. So I get that this. So then B is not 0. So then this is 0. And what I find is optimal entry, optimal fishing. So why is that 0? Well, because as long as there is some slight positive profit to be made from renting some other boat, then some fisherman is going to rent a boat. And then optimal fishing, it's all the fishermen decide together to limit the number of boats because they want to have some positive profit. So I find that by dB equals to, so it's exactly this. So if I derive with respect to the first this first B, I find exactly that. And if I derive with respect to this B inside here, then I find B, and then it's ds d equals 0. Yeah, and then what is special here is that ds dB is or S of B is a linear function of B. Because what I had was that yeah, S star B star equals K times 1 minus alpha B star divided by R. So what we find is that this thing there is just going to be, yeah, I can just compute it. Yes, star B star equals to minus K times. And if I substitute, I will find that actually this term is exactly the same as this term. So yeah, maybe a good way. And that's why I'm going to find that the number of bolts is exactly half of what I get in this condition. Yeah, so probably a good thing to do would be to show you the profit maximizing condition. Yeah, so you see, here is what happens when the industry sets profits to 0. So we fish here, but the marginal revenue is exactly half of the marginal profit or the profit curve. So this is exactly the same as when we did something with the monopoly, for instance. If you remember your microeconomics of the monopoly, when we had a linear demand function, then we always found that the marginal revenue was exactly 1/2 of the demand function. Well, the same mechanism happens. I have that the profit is this. So if I derive profit with respect to B, then I have this extra term here that appears that is 2. So I always find that B star O is exactly 1/2 of B star F. Yeah, so this is a mathematical result of the fact that I use these functions there. But obviously I could change the model, make it more complicated and not find this. But that's the intuition behind it. Yeah, so I shouldn't spend too long on that. That's something technical. I'm not going to ask you why is B star O exactly 1/2 of B star F. That's just an interesting result. Okay, so I would go back to this. So, okay, maybe I can ask, are there any other questions with respect to this part? So the natural resources. No, okay. If you think of anything, just ask me.
Yes.
Oh, go ahead.
This is not really linked with that part, but could you please put this document at the end of the course
Yes.
On the website, please?
Yes, yes, of course.
Great. Thank you.
Okay, when we consider the stock of population, do we consider the whole population or just workers? Oh yeah, so yeah, this is not a super profound question. It's just some technical questions. So yes, everybody's working. Either in harvesting or in other sector. Okay, slide 27 of chapter 2, why when S increases, the growth of S is negative. So I'm just going to reproduce this this equation there. So let me go back on oh yeah. So the equation is S of t of S dot equals S of t, which multiplies R minus R over K S of t minus alpha beta L of t. Oops, not G. Is that right? Yeah, I think it is. Okay, so the question is, so from this, yeah, I should ask that. From the so can somebody have an idea why this is the case? So this is the growth of the stock that we find in the Easter Island. It's equal to the stock itself, S of t, which multiplies R minus R divided by K S of t minus alpha beta LT. So why do we know that from the sustained island steady state, if S increases, the growth of S is negative?
We see it on the curve.
On the graph, you mean? On the
Yes, on the graph.
Yes, but so the curve on the graph is all the values of S and L such that S dot is 0. And now I'm asking, imagine that I start from some place where S dot is 0, and then I reduce S, so I'm away from that curve. How do I know that S dot is now going to be negative? Not so easy.
Because in the steady state, the is equal to 0. So when S increase from the steady state, so the second part is negative. So S at t is negative.
Yes, perfect. So I should add the following. So it's the sustained island steady state. So sustained island means that S is has some positive value. So if S dot is 0, it has to be because this is 0, right? So what I could do is simply, when I ask something like this, so what happens to the growth when some stuff changes, then you don't really have to think too much. You just, okay, let me derive. So let us take the derivative. So yeah. So ds t equals, well, I can derive with respect to this one, and I get this parenthesis, plus then I derive with respect to the s that's inside this parenthesis, which is this one. So then this, I don't need that. This, I don't need that. And I find this. And what do I know? Well, I know that I was at the sustained Eigen steady state, so there inside of the parenthesis was 0. So and so this is equal to simply minus. Yes. And then what is the interpretation of that? It's not such an easy question either.
Because it's negative, we can say that 1 unit from ST will decrease S dot.
Yes, so that's the mathematical fact. But so if you, what is the, so why does that make sense to describe the island, for instance?
Can we say that is like the fish?
Yes, it's the same sort of dynamic.
So if there are too many what resources, natural resources, the growth is negative.
Yes. So interpretation is, since they are in equilibrium, so if more we get closer to K, so to the carrying capacity. So it's more difficult for, say, for fishes or for nature to sustain itself. Knowing that there is exploitation, right? Okay, so perfect. TD2 exercise 3, question D. Oh yeah, the
And
presence of,
sorry,
Yeah, go
How
ahead.
do we know that R minus R over key ST minus alpha beta LT equal to 0? How do we know that?
Oh, it's the sustained island. So
Okay.
yeah,
Okay.
it's because you have different steady state, and that one is one where S is positive and L is positive.
Yes, thank you.
That's a perfectly valid question. If it could be that S was 0, and in that case, all right. So yeah, so that one is a bit tricky. So let me try to find this one. Exercise 3, what was it? Oh yeah, so I should have put that before. It's something about fishes. Oh yeah, it's quite technical actually. So how could I think the best is to just show you the so this is the solution with tipping point. So that's yeah, let me put that before I should have. So that's part of fishing. Okay. So what's going on there? So if t is 0, then this curve looks like this, right? And then if I add some threshold, then the curve is lower here, and it looks like this. So the higher the t, or the closer it gets to k, then you see that the range in which the nature can grow is very, very small, and it's higher. So that's what this sentence means. The percent of the threshold for positive growth t raises the value at which of st at which the fish population grows the fastest. So the value at which the fish population grows the fastest is the maximum here. So you see that if t is very high, then it's going to be probably like here, for instance. So I mean, it's not something super profound or anything. It's just that I had to ask you questions to make you think and work. But so yeah, that's the reality. If t was like super close to k, then you can see that the the only value at which the population could grow would be like just in the middle. So so that's what happened. So I don't want to dive too deep into that. It's just a mathematical fact. If you are a fisherman, then you are interested in this concept of maximum yield. So the quantity at which the growth is the fastest. So it's also the quantity at which you can exploit the resource, and it grows the fastest. Right. So if I have to answer, if t goes up, then the range S for growth becomes smaller and closer to key. Yeah, but this is really something technical. I don't know if I would ask something like that in the exam.
Mister,
Hmm?
I have a question on the same exercise, question G, with the second graph. I don't
Yeah.
understand what SS is a stable fishing.
Okay, yeah. So let me phrase that question. So TD2 question. So that's 3G, right? Yeah. So let me write this way. What's up with SS and SU? So let me do that again. Oh, okay. I'll try to do a better job. Okay, that's better. Yeah. So if there is no threshold, so this green line, which describes the growth of the resource, it starts at 0. And we found that no matter what is the no matter what happens, there's never going to be a collapse, basically. And here the question is, so what if I choose some value of B that's very high? Could there be a collapse? So what we have again to look is, okay, what happens in terms of catches? So the total catches are alpha times ST, so that's the number of catch per one boat, multiplied by B, the number of boats. So in terms of ST, you see that it's just a straight line like this, for instance. And then we can ask ourselves, so is there some value for which the industry is at equilibrium, some value for which the industry is out of equilibrium? So what would we need for that? Well, we would need that the total number of new fishes every year or every day, for instance, is the same as the total number of catches every day. So it's always the same, is that this line, for instance, is equal to the red line is equal to the green line. So here we see that it crosses in two places. So that's two potential steady states. So if there is this number of boats in the ocean, then you can have two places in which the fish stock is at equilibrium. And now I've written this stable fishing and this SU unstable fishing. So can somebody interpret this a bit to see if
It is stable if, for instance, if the S goes up or goes down in the future, it will always come back to the S point.
Perfect. Yes. So let's look at it. So, for instance, if the stock for some reason, so fishes are, so it's cold this year, so they have a bit less of strings. So S goes down a bit, and then we ask, so where is the stock going to be evolved? Then you look at, okay, what is the growth of the population? It's this. What is the exploitation? It's this. So the net growth is so the natural growth minus exploitation, it's positive. So S is going to go back to here. Same thing if S is too large, it's going to go back down. But imagine I was in this sad place where the stock is super small. Then what happens? Well, if it's a bit too cold, then I go down a bit, and then I see that, oh, there's more exploitation than natural reproduction. So S continues to decrease and decrease and decrease. And what's even worse is once I cross this place, then then it would mean that even when with no fishing at all, if this red line was 0, then once I'm in here, the fish population collapses all the time. So that's the interpretation. And here we see that a situation in which, imagine I have a very large number of boats. So there is absolutely no possible value of S for which these two are the same. So it means that the population would always, the fish stock would always crash to 0. So SS, steady state, or small deviation. Go back to the same. SU. Oh, and by the way, if I'm at SU and there is some slightly better than average growth, then where do I go?
To SS.
Yes. So did that answer the question?
Yes, thank you.
Okay, good. Is T the tipping point? Yes. Critical point. Okay. In the Malthusian model, does the little y correspond to technology or the output per capita? Can somebody answer that? So yeah, now we change chapter, chapter 3.
It's the output per capita.
Yes. When there's a sudden shock to the population, that it doesn't impact the maybe I didn't write this thing properly. So let me, I think how it was written is yeah, I think that was the question. So can somebody say?
It changes P.
Yes. But I could also say, what if the curve shifts? What happens? In the long run. So I can say both things. I can say, oh, there's an epidemic and P goes down, but the curve is the same. Where does P go back? Or I can say, let's imagine that the curve shifts. There's a shift in technology or something. Then what's going to happen to the population over time? So both questions are possible. When there's a change in production function, f of P, change the curve upward or downward. So yes, that's exactly that's exactly right. Yes, it shifts. Y equals y of P, or P of y. So it shifts the curve. Does the Malthusian theory is still checked nowadays? What do you think?
Of course not.
Yes, of course not. Let me see if I can find my graph. Well, it can be in some countries, but in most countries, I would say no. So yeah, now it's not positive anymore, it's negative. So rich people have fewer children. By the way, I just read a very interesting article 2 days ago. So we kind of observed Japan and ask ourselves, why is natality so low? Why do people don't marry and don't have kids? they're so weird. But then the article was saying, no, 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 it's not just Japan. In all countries, all advanced industrialized countries, the Y generation and the millennials and the younger people they marry later and they have fewer children. So it's really a demographic change about the attitude of young people. They just don't want to have as many children as before. So I mean, it looks like the baby boom was like the top of the reproduction event in the Western world, and now it's really going back down. Okay, chapter 4. I don't understand the consumption expense constraint. Oh yeah, so let me just. So that's chapter 4. Oh yeah, okay. So it was exactly, I'm just going to write it as it's written. So 0 smaller or equal to P plus 1 CT plus 1 smaller or equal to P plus 1 omega. Okay, can somebody have a idea? I don't understand the consumption expense constraint in period T plus 1. So that's how much I'm able to consume in period T plus 1. And so the right constraint is this one. So you have PT omega. And then the person to ask, why is it not PT plus 1 omega instead?
Because PT omega is the revenue to consume in the future, and it can't be with T plus 1 prices.
Just what's the end of the sentence?
It can be calculated with T plus 1 prices, but with prices in year T.
Yes, and so why are prices in period T relevant here and not prices in period T plus 1?
Because we don't know the prices in PT plus 1. Or in T plus 1, sorry.
Yeah, well, we can know them, but why don't they apply? Let me write my constraint in period T. So it's CT equals PT smaller or equal to PT omega, and I can even simplify this to so in period 1, the most I can consume is everything I produce omega. So does that Yeah.
I think it's because we exchange money in period T, so we we hold that amount of money, amount of money, and it depends on period T plus 1. No?
Yes, so let me rephrase this. So it is because I work in period T. So the amount of money I gain from exchanging omega for money depends on prices P. Oh. So we see it here. So in period T, if I want to consume everything, so I sell everything I produce, I get PT omega, and then I can consume everything. And so my expenditure is PT CT. Imagine. So what I can do instead is, and this is equal to, so yeah, this amount of money is PT omega. Not going to answer. If I was working in period T plus 1, then I would gain some income, but that would be omega T plus 1, PT plus 1. So yeah, so that's why. It's a good question. It's subtle, you know. Always have to ask yourself these things.
I have a question, sorry. As we consume a part of omega in period T, why do we still take into account the whole consumption possible in period T plus 1?
Oh, it's this is a constraint on it's the absolute so what this says is what are my choices in period T plus 1. So if I consume everything in period T, then what do I get to spend in period T plus 1? It's 0. If I consume nothing, what do I get to spend? It's well, it's this PT omega. And then if I consume some of it, but not all of it, then it's between 0 and PT omega. So it's just describing my choice set in period T plus 1.
Okay, thank you.
Okay, so yeah, in slide 23, we find that pi t minus 1 equals pi. So we conclude that there is deflation. Why not? Inflation equals 0. So we conclude that the inflation is the same each period because all growth is always the same. For instance, the population grows always at the same pace, so it means that inflation is going to be a reflection of that. But it doesn't mean that inflation is 0. And why is inflation positive? If somebody wants has some intuition, so let me find the formula. So I find this. So this is the money supply, the total money supply in the economy in period t-1. It's LT minus 1, the number of people multiplied by MT-1, the amount of money that these people have. And this is going to be equal to, so this is the amount of money that they want to exchange with the next generation. And the next generation is going to be LT. And they are going to want a certain amount MT. And this has to be the same for the market to clear for both part of the deal to be happy with the deal. And then what I can do is substitute LT minus 1 equals to then this was equal to 1 plus n times MT minus 1. So then, of course, I'm going to get rid of the MT minus 1. Yeah. Does that make sense? Oh, no, it's not M, it's L, sorry. LT minus 1 plus N. Yeah, I thought that this looked very suspicious. All right, so yeah, so I don't need to know how many people were in each generation. All I know is that this is the amount of money that everybody is going to have over time. So it's going to grow. Well, it's going to decrease because there is this 1 plus n. Yeah, if I substitute MT minus 1 was equal to PT minus 1 omega divided by 1 plus beta. This was equal to PT, and then same thing, omega beta over 1 plus beta. So then this goes away, this goes away, this goes away, this goes away. Yeah, so then all I can find is that I do that because this is inflation. Pi. This is Yeah. Is that it? Or, oh no, there's a minus there. Yeah. All right. So this is how we find the inflation. Obviously, at the exam, I would give you the formulas. I don't expect you to remember these things. It's but you know, it's good to remember how they look, what they look like. So you, oh yeah, that's what I found. So is there some interpretation why we find this this inflation, this deflation actually?
Just because it's negative? No.
Yeah. So why is there?
It's because the demand of money doesn't change, but the population increases. So the productivity stays constant. So the amount of goods created in the economy increases too.
Yes, exactly. So money supply is constant. So you could say it's big M. Big M equals to, it's just something that was created long ago by the founding fathers of the country. So it's equal to t minus 1, and it's equal to LTMT. So this doesn't change, but the number of goods services by increases because population increases. Yeah, exactly. So yeah. So then what would I imagine? I was the central bank and I could increase M. So if I wanted the prices to stay constant, what should I do? Should I increase or decrease M?
Increase.
Yes, exactly. So if there is too many goods to buy compared to the supply of money, then if I just increase the supply of money, then it's if both increase at the same pace, then the price, which is the exchange rate between money and goods, is always going to be the same because there's always the same quantity of money and goods to buy. So good. Oh, that's a French question. I was lazy. I didn't translate it. Yeah, exercise 3, question F. Okay. So let me find this one. Okay, yeah. Well, that's a bit technical. So the question is this one. State the market clearing condition in the bond market. Show that the market will only clear if 1 plus R, if beta. Question. Yeah, so that's must be hard for you to switch from one topic to the other. So yeah, sorry. That's the question I received. Do not find. Oops. Why is there some gap there? Oh, there it is. Okay. Yeah, so the okay, so yeah, it's a technical question. What I would say is the following. So to have a market, so both parties. Here we have I and E. I for impatient, I think, and E was for individual E and individual I, anyways. Need to be willing to exchange and able. So in the answer, we find that so there's only one person who produces something in the first period. So yeah, individual produces. Well, that's a very old question. I don't think I remember all the details, but I think it's this. So produces something in the first period. And exchange rate and preferences to be such he is willing to exchange some of it or to lend some of it. He who needs to borrow. And so yeah, so it's the two individual are the ones who are exchanged. There's no bank here. There's no. We don't assume any other intermediaries. It's just the question is, what is it possible for both people to have some money to exchange and to be willing to exchange it for some production right now to receive it back in the next period. So I don't want to go into details because it's complicated, but you can look at it if you want. All we describe is so that was the question that we were asking. Yeah, I'm not. Sorry, I'm not clear, but yeah, there are no. Speak of. By the way, in macro models, it's usually the case that we don't really care about banks. We just say, oh yeah, is there some people who are willing to lend some money to other people? And well, actually you need a model with heterogeneous agents to be able to have that. So here we have agent I, which is different from agent E because they both have their individual preferences and they all both have specific income at specific time. But if you want to model banks and what happens when banks do X, Y, or Z, then you need to add some bank in the model, but it makes the model more complicated. So yeah, it would be confusing for me to start describing all the exercise. If you don't remember, go back and redo the exercise. Is TD1 in the program? No. Oh yeah, I wrote it here. TD1 is not included in the program. We need to know all the formulas of chapter 2. I wrote that here. Not have to memorize them, but it's good to know what they look like. So in the exam, if you're doing some computation, you know you're not lost. You haven't made a mistake. Do we need to know the case studies, Brazil, Weimar Republic? It's good to know the big ideas behind them. So I'm never going to ask you something specific about the dates but understand generally why the episode started. So was it because there was some excessive money printing, or was it because there was a recession or a war? And then how it ended. So was it because there was some new currency that was backed by something, or in Brazil, was it because they tricked people into accepting that the currency was stable over time? So these kind of things. Zimbabwe, I spoke about it really at the end. So I would say it's extra. You don't have to remember the details about the Zimbabwe. All right. So any extra questions?
Yes. Will you put this on the Moodle? Yes.
Well, on the website. Oh, and by the way, so it's unmanaged exam. Oh, do you know when it is?
Next
On Tuesday?
Yeah, but at what time?
At 8:45.
Ah, so it means if there's a problem, they're going to call me in the middle of the night. Oh, anyways. Yeah, so it's unmanaged exam. So yeah, they don't allow you to create things like two separate versions of the exam or stuff. So I thought, okay, I'm not going to overburden the exam. I'm just going to write it all in English. But then I've got some terrorized students saying, no, I cannot survive if there's not a French version. So then what I did is everywhere I wrote like the thing in English and then the same thing in French with in italic. So it's a bit, it looks long, but all the questions are reproduced twice. Once in English, once in French. Yeah.
And when you say we can check all the answer because there are no negative points.
Yes.
If we if we check two answer in one question, and one is good and one is wrong.
I think you cannot do that. So there's only one. There's always one single right answer.
Okay.
But so the way for me to get around this is to say, for instance, like A, B, C, D, E, F, and then say maybe is A, B, C the right answer, or B, C, D the right answer, or this would be 1, this would be 2, and then etc. So that way I can ask questions with multiple answers, but that's the way to go around it.
There is only a single choice, no?
Yes.
A single answer. Okay.
And it's automatic, so you're going to know your result very fast.
Okay.
But the sad part is you cannot, if you're unsure, you cannot write in the margin, oh, maybe I thought it was this, and then I couldn't take that into account. It's just what it is. All right.
Sorry, this document will be on Moodle, right? Or do you
on the website?
On the website. Okay, nice, awesome. Thank you very much. And of course, no questions on chapter 1, it being the lesson and the TD, nothing on it.
Yeah, nothing on it. But I've had some students saying, so this I can tell you. So yeah, because the goal of as a student, I understand, is to understand what not to study. So the question is, oh yeah, but in TD3 or 4 or 5 or 4, yeah, some questions look like solo. Are they included? So I said everything from TD2 and chapter 2 onwards. So yes. That said, if I were you, I would still try to have some probabilistic way of thinking and understand that we saw so much new stuff after the exam. So I'm not going to have some huge question about solo that look like some. So if there's, I'm not obviously not going to tell you there's nothing at all. Because if there are some solo parts in the TDs, then that's it. But yeah, so try to be strategic in the way you study.
Thank you very much.
All right. Okay, so let's say it's finished for the last extra lecture, and I'm going to put that on the website and probably the video too, if I'm motivated. And yeah, and you can still send me questions by email. I'm going to answer them. So have a nice end of your day.
Thank you.
Thank you. Bye.
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 Thank you. Bye.
Thank you. Goodbye.